Hello. Design systems are apparently very popular nowadays. Yeah, so popular that, and this is the bit that I find interesting, even if you're not building a design system or if you don't have one, chances are that the kind of design systems thinking is subtly influencing the way you're building your user interfaces. So this talk is about user interface building, not strictly speaking about design systems. I'm going to run through a couple of tools which are very in tune with this design systems thinking, which you may or may not be using. And not build tools or anything of the sort, but tools for thinking about process and architecture. And one of them's from the design field of things, and the other one's from the dev field, so hopefully there'll be a little bit of something for everyone here. To start off, atomic design. It's a methodology that was created by US designer Brad Frost. And the basic premise of it is that complex designs can be broken down into super simple components. And he uses chemistry as a model and goes, you have atoms, which are really, really basic components. Atoms stick together to form molecules, and then molecules stick together to form organisms, and then you break out of the chemistry thing completely, and you're onto templates and pages. So templates are your basic layouts, and pages should be the finished product with actual content and data and whatnot inside it. And the purpose of this is that your atoms should be infinitely reusable. So the same atom will go into several different molecules, same molecule will go into several different organisms, and hopefully this will help you achieve consistency in your design because you're not making up every little bit from scratch. So let's look at an actual example. Now, this is an image gallery, and it sits somewhere on a page in the depths of the internet. So it's probably an organism, the whole thing in itself, but you can break it down into small bits. So for instance, the image should be an atom. You can't break an image down any further. And those are, hopefully everyone can see that there are navigation buttons on the left and the right-hand side of the image. And those two navigation buttons together would probably be a molecule. But then you have a little counter on the top right-hand side that tells you what place you are in the navigation. Now, that should probably be part of the navigation because it's kind of conceptually associated with it. But now we come to a problem, which is this little thumbnail strip down the bottom. It also has navigation. And the buttons are quite similar to the buttons up top. So we should probably be reusing our navigation molecule down here too. But this version of the molecule does not have the counter, so we probably have to make the counter optional or something. Okay, now what about the thumbnail strip itself? It's obviously a part of the image gallery. In a way, it is navigation of another sort. So it's part of an organism. Should it be a molecule? But it contains a navigation, which is already a molecule. So can we nest molecules? Or what if, wait, if it's got a molecule, maybe it's an organism. So can we nest organisms? Or should we be thinking about creating a whole new level in the hierarchy so that we can accommodate all these steps? And at this point, the whole team is probably arguing amongst themselves because everyone has strong opinions on these matters and no one ever agrees. And you start to consider throwing the whole thing out the window. The answer to this is, if there's an answer, all of these options are potentially correct. There's not one right way to do it, except I would be wary about the creating intermediate levels thing unless you have a deep love of bureaucratic procedure, because that's the way you're going. But other than that, it's a pretty flexible system because it can accommodate several ways of doing things. Now, the problem with the atomic design idea is it looks too much like a linear progression. You start with atoms, and then from those atoms you build molecules, and from those molecules you build organisms. And you see the way this is going. It's sort of an evolutionary narrative. And the problem with that is humans love linearity. We love these stories about starting with little things and then becoming progressively more complex. So it's easy to think that, oh, what I've got to do here is I've got to build all my atoms first, and then I've got to build the molecules on top of those atoms, and then I'll have to build the organisms from the molecules. But that's not quite how design works. That's not quite how people work. You work sort of from top to bottom and bottom to top, and everything's happening at once, and you've got your sort of overall design, and you're building your atoms and your molecules, and everything's sort of happening simultaneously, it's a bit more chaotic than this system would make it appear. And the interesting thing is, that's also how code works, because no one starts with building tiny, clean little components and then composing a whole interface out of it. You normally write a chunk of code and then you go, hang on a second, I'm repeating myself here, so I'll extract this into a reusable function. So you kind of start messy and you clean up as you go along. So there's quite a similarity in the design and the code methodologies. So you start with a big messy blob and then you sort it out into your components. So because we're designing with a view of coding, and I'm assuming that this is going to be a somewhat waterfall process because design usually more or less happens first, even if you're agile, you know, it's sort of, it starts with design and it flows into dev. Let me know if you think, I'm always happy to hear other people's opinions on this. So if we've started out with a messy thing and in the design, we've created our atomic components, how does this translate into code? Because we've had the messy into neat and tidy with the design process, do we have to go over that all again when we build the code? We have to start messing, or can we just start building nice, neat little code components out of those atoms, molecules, and organisms? Now, to start attempting to answer this question, let's look into the second tool that I'm talking about today. And this is a pattern that comes from the React ecosystem. And it could, I guess you could apply it with other JavaScript frameworks, but React's the most popular one at the moment, so that's sort of what I'm talking about. And it was made popular, it wasn't created, but it was made popular by a big guy in the React community, Dan Abramov. So he created Redux, and he's sort of an all-around JavaScript celebrity. When he blogged about this back in 2015, everyone paid attention. People started adopting this system. It's quite interesting. So in React, everything is components. You pretty much build your whole interface out of neat, separate components. And the theory here is that in order to make your code base easier to reason about, you should divide it into two separate types of components. Now, container components will contain your business logic. That's where you do all your data fetching, trying to figure out what you should be rendering and why, and manipulation of data, state management, all those things. And the presentational components are the ones where you actually have your visible bits of UI. So all your markup and your styling should be in there. And React is perfectly suited to this sort of division because, actually, I skipped a slide there. React is perfectly suited to this because it allows you to create components in two different ways. You can create them as classes, and the classes allow you to have more complex logic. They allow you to manage state. They have a bunch of methods that you can use to do all sorts of stuff in them. And you can create components as functions, which are kind of basic because they only allow you to put something in and then output something straight away. So it's like give it some data and then output some markup with that data inside it. So they're perfectly suited to the presentational components. Now, change in naming, because presentation is a bit of a mouthful, I prefer to call those UI components. But this is not only a change in naming, it's kind of a change in what it means to, because UI is more than strictly presentational. And especially if you think about HTML. HTML isn't presentational at all, really. It's functional, it's semantic, it's structural, and above all, it contains state. You can manage state inside your HTML. So here is where things get complicated. So just an example of your normal HTML behavior. You have, for instance, inputs, which might be invalid or checked. You have links, which also have states like visited. You have images where you can put in a source set component, which tells the browser which image it should be sending out, depending on what the size of the viewport is. So you have all sorts of complicated logic happening in vanilla HTML itself. And on top of that, if you're creating a user interface with any complexity at all, you're probably going to build other things. So another example, here's a button. I hope everyone can see that button. It's kind of like colored up there. Now, this button, when you click it, is supposed to open a drop-down. If you're using the keyboard to navigate, then you probably expect that when you click on that drop-down, your focus is transferred to inside of it, because you need to be able to tab through all those options. And to do that in React, you have to create a reference to that first focusable component so that you then listen to the click event, and when the button's clicked, you transfer focus inside the dropdown. And to do that, you need to create a class component. You can't really do that. Well, you can kind of use references in a way in functional components, but it won't work very well with this example. So you need to create a class component. So you've already got a bunch of complicated logic inside of your very simple UI component that was supposed to only take data and output markup. And that's not counting that you have to remember that when you click outside of that dropdown, it's expected to close, so then you have to add a click handler to the document. And okay, this is already several levels of complexity above what we expected our simple UI components to be. But this is not really a huge problem. Because about a year after Dan Abramov wrote that original post, he went on Twitter going, hey, people are taking this way too seriously. I didn't mean that you had to strictly divide everything into presentational container and do it this way, like relax people, it's okay. And yes, it's okay, like you don't have to strictly adhere to these rules. You have to be a bit sensible about when to use them and how. But that's not to say that this isn't a useful division, because what it allows us to do is focus on the UI components, which are the things that you're probably going to be building when you translate your neat atomic design into actual code, and leave the other stuff that is not strictly UI related, or the data fetching and whatnot, and put it separately. And especially if you're building a design system, what makes sense to have inside your design system is that what's on that side. Okay, so cool. So we have our atoms and molecules and organisms inside UI components, and that makes perfect sense. But are we going to build a UI component for each of these little things? So back to our question. Well, let's have a look at another example. Here's a button. The button is the perfect example of a component. It's used in every single talk about UI, about design system. The button is what they always come up with, because it's the most interesting HTML element, right? No one would want to make an example out of a paragraph or a span, or God forbid a div, like they don't really do anything. But the button is interactive, it has state, you can do all sorts of stuff with it. So, cool. So how do we make a button component? Now, I hope this code is readable. It's on a slide, I'm gonna have trouble zooming in, but this is what a button would look like in React. It takes a value, it takes a click handler, it outputs a piece of HTML markup with a class name. The CSS is in another file. So the whole file with just the markup, as I said, the CSS is separate, is about 26 lines long. And that's to output a single line of HTML. And I can tell you with confidence that the code base from which this example is extracted has used this component only once. Right, what went wrong here? To go into what went wrong, I will show you an example of another button from the same code base. Now, this button is pretty specific. It wasn't built with intent to be reusable. So it's a button somewhere in the comments component. It's got on click, on mouse over, on touch start. It's got a couple of ARIA attributes for accessibility purposes. You can tell from the fact that it has an ARIA expanded that it's probably got a drop down or an accordion of some sort attached to it. And further to that, there's an alternative state where if those comments aren't active, it actually outputs a different button, a disable button, because you're not supposed to be able to use that component if there are no comments. Okay, so this is pretty specific. Now, if we wanted to have a single button element, we might go back to our original component and try to stick all this functionality in there, but we'd probably end up with that, about 100 lines of code, not counting the CSS, and there'd be several variants to that too. And is that really what we want? I mean, I know that the quality is not the quality of a code base is not in inverse proportion to the amount of lines it has, but you don't really want to be writing unnecessary code. And the thing with buttons is they are already an HTML element. An HTML element is a component in itself. It does stuff. So do you really need to wrap a component around that? But wait, you say, all the buttons on my website or application need to be consistent in terms of their styling, because otherwise how do people know that this is one thing and it has, I need to show my brand identity with my buttons. And that's okay, because there's this wonderful, useful thing called CSS. You can actually create reusable chunks of CSS. In this case, I'm using Sass, so I've got a mix in here that outputs a bunch of styles. But if you're using CSS in JavaScript, you could write that up as an object, put your CSS styles in there, and just import it into the file where your button is. It's fine, it's easy. Not a problem at all. So we don't have to have a strict one-to-one correspondence between the atomic design elements and the markup or the React components or whatnot. The thing to bear in mind is we should do it when it's sensible. It's not because someone created an atom that you should go, okay, this needs to be a discrete component, because code doesn't work exactly in the same way as design. It's a translation process. It's not, and translation is not literal. Translation needs to take into account the context of what you're translating to. So it's perfectly fine, and neither designers or developers are going to get upset if there's not a one-to-one correspondence between the two things. I'll tell you what does make designers and developers burst into tears: naming inconsistencies. So if the devs are all talking about buttons and the designer comes up and goes, we need to put in a call to action here, and the dev goes, oh, call to action, that's a new component, we have to go and build that. So make sure everyone's talking the same language. If we're calling the same things by the same names, then we're halfway there. And that's kind of the fundamental purpose of design systems, really. It's sort of a communication tool to enable people to make sure that they're on the same page. It's just another tool. So, in conclusion, modularity is great, and that's one of the sort of design system fundamental principles. And the tools that I've been talking about here will help you achieve this. Whether you have a design system or not, they're still great tools. But remember not to take them too seriously, because you kind of need to adapt them to your working environment and to your problems that you need to solve. And even if you don't have a design system, you make sure that your code is clean and reusable and have tests. You can never have too many tests. And make sure that everything is properly documented. That's where the design system might come in handy, but your mileage may vary. Make sure, above all, that everyone is speaking the same language within the team. Because ultimately, what we all want to do is make things a bit better than we found them. And that's me.